Hello, I'm Art McIntyre, Building Science Engineer for the Seed Home. As we've discussed, our building envelope starts at the slab and foundation and continues through the walls and up to the attic and/or roof. At this point of our tour, let's look at the part of the envelope that consists of our above-grade walls. Above-grade walls are one of the areas of the envelope that allow for several different options for construction. From cast-in-place ICF to prefabricated SIP panels as seen in our garage, to more conventional site-built structures, any of these forms of construction can be made to perform well if we pay attention to the details. For the entire wall assembly, we must identify and address air sealing issues, design a continuous insulation plane, and understand what the average insulation level for the entire assembly is, including all materials, windows, doors, and insulation, and not just looking at cavity insulation. We need a wall that will defend against exterior bulk water intrusion as well as reduce condensation potential within the wall and allow trapped moisture in the wall to dry over time. Earlier we learned to identify the air sealing layer of the envelope. Now we need to look at that layer and identify all possible leakage points and devise a method to seal them. These would include the wall joints of a SIP panel, window bucks and plates of an ICF. For conventional framing would include sill plates, wall intersections, window and door openings, mechanical and electrical penetrations, and so on. Plan to seal those areas separately from the insulation installation using resilient sealants such as adhesive caulks, spray foams. Do not expect your insulation material to be your air seal. The more thought through your air seal, the better the building will perform. In addition to the air seal, it is important to have a continuous insulation layer on the exterior of the wall. The more continuous insulation versus cavity insulation, the higher the average R value of the wall becomes. For our weather zone, a minimum continuous layer of R5 is recommended, and the more, the better. Today, more and more homes are being built with an R10 to an R20 continuous layer. Having this continuous layer provides a complete thermal break between conditioned and unconditioned space. Along with reduced framing material and better wall configuration, this increases the overall R value of the wall, greatly reducing conductive losses from the building. As we decrease infiltration and increase insulation levels of our walls, we cannot overlook durability. Our tighter walls are much more susceptible to moisture. Walls have a continuous and flash drainage layer on the exterior, with importance applied to the continuous and uninterrupted to ensure bulk moisture from rain and snow does not penetrate the wall assembly. Additionally, walls with an adequate level of continuous exterior insulation will reduce the potential for condensation on the interior of the wall. Condensation occurs when humid interior air moves into the wall cavity and condenses on cold surfaces, which is often the backside of the wall sheeting. Exterior foam raises the surface temperature enough to greatly reduce the potential for condensation. Lastly, if moisture does enter into the wall cavity through bulk water or condensation, the wall needs to be resistant to absorbing the moisture and be able to dry over time. Replacing wood sheeting with foam provides a more robust material against moisture. Avoiding low permeance building materials allows the moisture to dry from the cavity over time. Examples of low permeance materials would be polyethylene plastic, several layers of paint, vinyl wallpaper, and any material that does not allow moisture to readily diffuse through it should be avoided on the interior of the wall assembly in a cold climate region such as ours. As you can see, wall assemblies can be very complex, and this tour only scratches the surface of the knowledge needed to ensure the durability of high-performing assembly. It is highly encouraged when designing and constructing a home, seek out the expertise of building science and performance to provide a sound, high-performance design.